Good morning everyone. Today we will create an ERC20 token using Solidity and React. Today I will be with my iced coffee. I want to create an ICO to sell my tokens. The price of each token in the ICO I want to be always $50. Also, I want to show the amount of ETH that this ICO is funded, the number of transactions, the number of tokens that you have, and a list that shows the last 10 transactions. To create this project, I will use React and ChakraUI to make the user interface of the website, Solidity to create our smart contracts, Zeppelin to get some default ERC20 contract, ChainLink to get the current price of the ETH in a decentralized way, Truffle Suite to compile and deploy our smart contracts, Infura to connect our DAPP with a testnet, Metamask as a wallet, a Faucet to receive some ETH to get some tokens, and EtherScan to see all the info about the transactions and the smart contracts that we deploy. If you want to use this DAPP from your smartphone, you will have to use the Metamask browser. I remind you that all the code of this project will be in my GitHub repo, and the link to this GitHub repo will be in the description of the video. Well, first of all, we create our React project. I am using, for this case, Next.js and TypeScript, but you don't have to do the same. You can use just React. Once we have our project, we move to the project folder, and then we init Truffle using the command Truffle init. If you don't have Truffle installed, you can install it using the next command, npm install Truffle, and then you can start to use Truffle. Once we have our Truffle project, we will see new folders and new files like contracts, migrations, or the Truffle config file. In this file, we will see an entire commented file where we will have to modify to config our Truffle project to work with a testnet. First of all, we will have to uncomment the Robson config. Robson is a testnet that Truffle brings us by default to use. But like I will use Koban as a testnet, I will have to modify some things in this testnet config. After that, we continue scrolling down until we find the compiler section, where we will have to uncomment the settings and set the optimizer to true. Now we see how looks the final config that I will use in this project. We can see new things in this config, but relax, that I will explain to you step by step all the new things about this config. First, we will have to get Truffle HD wallet installed. This is a Truffle tool that doesn't come with the default tools of Truffle, so we have to install it separately. Once we have Truffle HD wallet installed, we create an instance of this tool just like you see on the video. We implement the Truffle HD wallet provider in our React testnet config like this. You can see how I paste some data inside of the HD wallet provider. This data is necessary to work correctly with our testnet. So now I will explain all of these parameters. The private keys are just the private keys of our wallet that we will use to deploy and test our smart contracts. We create an array of private keys like you can see, and here we will have to paste all the private keys of our wallet. To get this private key, we will have to go to Metamask or the wallet that you use and get the private key. And finally, we paste this private key on the private key array. Here we see how I set number of addresses on 2. But it was only because when I recorded this video, I thought that I will have to use 2 wallets to test and deploy the smart contract. But then I realized that I can set only 1 wallet. So finally, I put 1 inside of 2. To connect with our testnet network, we will have to have an Infura account. So we create and confirm an Infura account. Then we can create an Infura project. We have to set the product on Ethereum, and we can set any name that we want. After that, we can copy the link that Infura provides us, and finally paste it on the provider or URL variable. It's important that you check that the endpoints it's set on the Koban testnet or any testnet that you will use, because you can copy another link that connects you with another testnet or also the mainnet of Ethereum. Finally, we have to set the correct network ID for the testnet that you will use. In this case, I will use the Koban testnet, so I will search the network ID for this testnet. Once we know the correct network ID, we have to set this number inside of the Truffle config file. To create our token contract, we will use some contracts from Zeppelin. Like the ERC20 tokens have the same structure as each other, Zeppelin provides us a default contract to create our ERC20 token. To use this kind of contract that Zeppelin provides us, first we will have to install the npm package of Zeppelin using this command. Now we can finally use the contract of Zeppelin. We see how Zeppelin shows in his documentation how they create an ERC20 token. So we create a Solidity file and then we implement our token like this. In the constructor, we set our ERC20, passing the name of our token and the symbol too. Inside of the constructor, we execute a main function where we finally create the token. Here we pass 2 parameters. First, the address of the account that creates the token, and then the amount of tokens that we will create in way, and it's important. So in this case, I will create 1 billion of tokens, but I have to multiply this number for 10 raised to 18, because that is the expression of 1 billion of tokens in way. For those that don't know what is way, it is the smallest expression of an ether. If we see the ERC20 contract that Zeppelin provides us, we will see all the functions that an ERC20 token will have, like the name function, the symbol, the decimals, total supply, balance of, transfer, allowance, and so on. To create an ICO, we will have to have a smart contract who handles the sale of tokens. Like, I want that in the ICO the tokens always cost $50, I will have to use some API to get the current price of the Ethereum. But like, using a centralized API will be against of the blockchain community. We are obligated to use some decentralized API. Fortunately, ChainLink provides a great API that allows you to get the current price of any cryptocurrency in real time. This isn't an API. It's a smart contract that stores the current price of the cryptocurrency, but works like an API. In his documentation, ChainLink shows us how to implement it. We see that we will have to use some aggregator v3 interface, so we will have to install it. And then we can use the aggregator v3 interface to get an instance of the smart contract that provides us the current price of the Ethereum. In the contract cell, I have some variables that will help me to get some values that I want to show in the website of the ICO, like token sold or token price in USD, the transaction count, and well, also I stored an address variable called ATH funds, where here I stored the address where all the ETH that you will send me to get your Faucet tokens, the ETH that you send me will store in this address, in this wallet. So I have to create some payable address like this to transfer in this contract. Later we will see how I transfer to this address the ETH that you will send me to get these Faucet tokens. And well, I store there in this address all the ETH that the ICO will generate. I also create an event structure, like you can see, the event cell, where we receive two parameters. The first, the address of the buyer, the new owner of these new tokens, and the second parameter will be the amount of the tokens that this buyer bought. I create a struct of transactions where we can pass the address of the buyer and also the amount of tokens that this address bought. Also, I create a mapping function called transaction, where I receive a unique ID, an integer, and I will return a transaction. So when I want to get a transaction, I will use this mapping function and I will pass some ID, and then I will get a transaction. In the constructor, I will create an instance of the smart contract that ChainLink provide us, like we see in the documentation of ChainLink. After that, I set the token price on $50. Later, I get an instance of the token, the Faucet token, that I receive as a parameter on the constructor. And finally, I set the admin of this smart contract using message.sender, who is the address of the wallet that deployed this smart contract. And also I have to unwrap this address with a payable function, because if I want to send some Ether to this account, I have to unwrap the address using a payable function. If I don't unwrap the address using a payable function, I cannot send Ether to this account because it isn't a payable address. So I have to unwrap the address using payable. Like we see in the documentation of ChainLink, we get the price of the Ethereum using a similar function that ChainLink shows us. Instead of set the name of each variable that the function of ChainLink returns, I just want to get the price of the Ethereum, so I left blank spaces in the variables that I don't want to use. And like we receive from the ChainLink function the current price of the Ethereum in GWay, I will return the amount divided by 10 to the power of 8. In the buy tokens function, we will receive the amount of tokens that the sender wants to buy. First, we get the current price of the token in ETH. After that, we check if the buyer sent enough ETH to buy these tokens. Later, we check that the contract sale has enough tokens to make the transfer. After that, we make the transactions inside of a required function, because the transfer function will return a Boolean variable, and if that returns false, the function will stop there. Once we make the transaction, we transfer the ETH that the buyer sent us to the wallet that will store all the ETH that the ICO will get. Increase the amount of tokens, set the transaction inside of the mapping function, increase the amount of transaction, and finally emit the sale event. The end sale function works to end the ICO. This function only can be called by the admin. So because of that, we require that in the first line of the function. We get an instance of the amount of tokens that the contract sale gets. We get an instance of the amount of tokens that the contract sale has. And after that, we make the transfer inside a required function. And then we destroy the contract using the self-destruct function. We have to compile our smart contract using the command truffle compile. Then we will have to deploy our smart contract to the blockchain. Like I am using the Koban testnet, I have to use this command. But if you use another testnet instead of Koban, you have to put the name of the testnet that you will use. Once our smart contracts are deployed, we will see a lot of information about the deployment. Here we copy the address of the contract token, and we check that everything goes well in EtherScan. Here we paste the address and we will see all the information about our new token. For example, the transactions. In this case, it will be only one transaction, and if you see in detail, we will see that the address who create the contract token, it's the same address that I have in Metamask. In EtherScan, we can see a lot of information about a simple transaction, from the address of the account that creates the contract until the transaction fee. To deploy the smart contracts, we have to have the migration file like this. Here I have some issues when I deploy the contract, because using this code, the code that isn't commented, Truffle only deploys the contract token. The contract sale token doesn't deploy. So I have to do two deployments. The first one using the uncomment code, and secondly using the comment code. In this code, I use the address of the contract token to pass it as a parameter in the contract sale token. Now that we have all of our smart contracts deployed, we have to transfer some tokens to the contract sale. Because now the contract sale has 0 tokens, and it will be impossible to sell tokens. To do that, we open the Truffle console, indicating that we will be using a testnet like we do to deploy our smart contracts. Here we get an instance of the smart contracts that we deployed. I paste the address of the contract sale in EtherScan because I want to see all in deep. Like we work in Way, we have to work with big ints to get a successful transfer. So I store in a variable the amount of tokens that I want to have the contract sale, and after that we just made the transfer, passing the address of the contract sale as the first parameter and the amount of tokens in Way as the second parameter. Finally, in EtherScan, we will see that we have our tokens. To set our token inside of Metamask, we have to have the address of the contract token. Then, in Metamask, import a token and paste the address of our token. Obviously, all inside of the Koban testnet. For the user interface, I will use a component library called ChakraUI. I really like this library because I can make beautiful UIs quickly. If you are interested in this library, I have a video on my YouTube channel where I explain ChakraUI in depth. Anyways, I will store in different variables the data that we will get from our smart contract using useState. And to get this data, I wrote a function that handles that. To refresh the data that the user can see, I like to use a state variable. So I have to indicate when I want to refresh the data. After that, we call a function that will return an object that contains all the data that we need to make the user interface. We will see this load function in div later. Now we can see how I made the buy tokens function. I have to store the amount of tokens in Way as a big int and then pass it as a parameter to the buy tokens function that the contract sale has. Also, I pass some metadata necessary to make a successful transfer. In the from, we pass the account of the user and we store that in the account state variable. In value, we pass the amount of ETH that the buyer has to send to get the tokens. And in the gas, we pass some number for the gas limit that we want to spend. In this case, I put 500,000 as a gas limit. This value will almost be fine, but in some cases, you will get an error because your gas limit is too low. To get the data from our smart contracts, we will create a function that I call load, and in this function we'll return an object that contains all the data from the smart contract. To get this data, we will need to import the JSON files that are created when we deploy the smart contracts. And also, we will need an instance of the Truffle contract function. To get this function, we will need to install the npm package of Truffle contracts. First, we will have to connect our app with Web3. So to do that, Metamask provides us a default code that connects our app with Metamask and the Web3. You will have the link to get this code in the description of the video. To get all the data, the load function will call other functions that get some data from our smart contracts. First, we get the account of the current user. To do this, we use the Web3 function get Coinbase. After that, we get an instance of the smart contract. To do that, we will use the contract function that the Truffle contract provides us. We will pass the JSON file of the smart contract to the contract function, and then we will get an instance of the smart contract. After that, we have to get the instance of the contract deployed, and finally returns the contracts. Once we have the instance of our smart contracts, we have to get all the data that we need. The loadVariables function will receive the contract sale token and will return an object that contains all the data from the smart contract. First, we get the amount of ETH that we have in our found wallet. To get that, we use the Web3 function getBalance. Now, we will get the transaction count that the contract sale made. To do that, we will use a public function that we create in our smart contract called transaction count. We have to transform this uint 256 to a number. Later, we have to get the tokens that we sold. To get that, we will use a public function that we create in our smart contract called token sold. Like we will get these tokens in Way, we have to transform this on ETH. To do that, we will use another Web3 function called fromWay, and we pass the amount and secondly in the format that we want. In this case is Ether. After that, we get the current price of the ETH using the public function that we create in our smart contract called getETHPrice. And then we transform the uint 256 to a simple number. Finally, we get the last 10 transactions using this strange for loop. I set the I variable with the last index of the transactions. The for loop will execute if the I variable is major or equal to 0, and if the j variable is less than 10. And every time that this for loop executes, the I variable will decrease so we can get the last 10 transactions of a huge array. Now we read the data that we return from the load function. Once we get the object, I simply set the state variables with the data from the load function. Now we have to test our ICO project. We can see how I have some errors. First, I don't have Web3 installed, so I have to install it. Now run again, and I have another error. I forgot to install Truffle contract, so I have to install it. We run again, and finally we can see how now it works. Before recording this, I made a transaction test for 3 tokens. So you can see that the number of transaction is 1, the ETH fund is 0.06 Ether, and in the transaction list shows the only one transaction that this ICO has. Like I am using the account that deploys the contract, I have 250 millions of tokens. We can also see all of this information on EtherScan, since the amount of tokens that this address has until the last transaction that I made. Now, if we see in EtherScan the contract sale token, we will see how this contract has 750 millions of tokens. So if we change the account of Metamask, we will see how the amount of tokens that this address has changed to 0. So if we try to buy some tokens with this new account, we will see how Metamask told us that we don't have enough ETH to make this transaction. So to get some fake ETH to make this transaction, I put a link button that redirects us to a Coban Faucet where we can get some fake ETH to interact with our smart contracts. Here we pass our address and we get the fake ETH to make the transactions and wherever. Now we can try again. And finally we will see that we can buy tokens successfully. Well, I hope that you really enjoyed the video, and of course that you learned something about blockchain development, and that you could get the main idea of doing a token, an ERC20 token, and the project of an ICO. So see you on another video.